How does conduction impact cooling system design? Imagine a hot metal rod touching a cooler surface. The heat flows from the hot to the cold part, right? That process is called conduction, and it plays a big role in designing cooling systems. When engineers design cooling systems, they need to understand how heat moves through solid materials. This helps them decide what materials to use and how to shape components to keep things from overheating. Conduction happens because molecules in solids vibrate and bump into each other, transferring heat. The speed of this heat transfer depends on the material's thermal conductivity. Metals like copper and aluminum have high thermal conductivity, so they transfer heat quickly. That's why they are often used in heat sinks and cooling fins. On the other hand, materials like plastics or ceramics have low thermal conductivity and act as insulators, slowing down heat flow. The thickness of the material also matters. Thinner walls or fins allow heat to pass through faster because the heat doesn't have to travel as far. But there is a limit because these parts need to be strong enough to hold up under mechanical stress. Engineers must find a balance between making parts thin enough for good conduction and thick enough for durability. Good contact between parts is essential too. If there are gaps or poor contact surfaces, thermal resistance increases, meaning heat doesn't transfer efficiently. For example, if a heat sink isn't tightly pressed against a chip, heat will build up. To reduce this resistance, engineers often use thermal paste or pads to improve contact. Managing thermal resistance is key. The total resistance to heat flow includes conduction through solid parts and convection at the interfaces with fluids like air or water. Minimizing conduction resistance helps improve overall cooling. For example, in engine cooling channels, the walls are designed to conduct heat away from hot engine parts to the coolant flowing inside. The wall thickness and fin design are carefully chosen to optimize heat transfer without sacrificing strength. In rocket engines, the hot chamber walls conduct heat to coolant channels. Engineers make the walls very thin and add fins to increase surface area, helping transfer heat quickly. They also consider how the shape and size of cooling channels affect conduction paths. More channels mean faster coolant flow and better heat removal, but the conduction through the walls must be efficient to transfer heat from the hot surface to the coolant. Sometimes, conduction can happen unintentionally. Wiring, mounting hardware, or other components can create unwanted heat paths. These need to be considered to prevent heat leaks that could cause components to overheat or waste energy. In the end, conduction influences many parts of cooling system design. It determines how heat moves through solid parts, guides material choices, and affects the shape and size of components. Properly managing conduction helps keep systems cool, protects parts, and ensures everything runs smoothly.